Hello everyone. Today we're going to talk about insertion sort. Again, we have two arrays, array A and B. We're going to sort these two arrays both using the insertion sort. So on the right side of the board, we have the pseudocode for the insertion sort. So the algorithm works in this way. You are picking a number, a key in the array, okay, then you're comparing that like all other numbers that are on the lower index of the array, okay, and then if there are those numbers are bigger than the key that you're choosing, then you are shifting the numbers to the right of the array. Okay, so like the key is the value that if it's smaller than the other values, so you're moving into the left. So let's do it with with the example array A here. I'd like to see how the insertion sort works. So first of all, I is equal to 1. So again, like most of the sorting algorithm, we have indexes to access the values of an array. So we have I equal to 1, and I have k, or key, that is equal to the location value of the location I, that is equal to 3. So my key is equal to 3. Now I'm going to check all other values that are on the lower index of this array with this key. So j first is equal to 0, that is I equal to 1, so that's the lower index. Now I'm comparing a allocation j that is equal to 7 with the key that is number 3. So because now 7 is greater than k, that's key, so what I'm going to do is I'm going to update the value at location aj plus 1, that is exactly the location of key, with the value that I have here. So what happens is, if I have 7, 3, 2, 9, 4, and 8 here, so I'm updating this one with the value 7, okay? But we shouldn't be worried about number 3 because I have the number 3 here kept as the key. So I'm decreasing j, so j becomes -1, okay? J becomes -1, so I'm not running this while loop again because j now is not not greater than or equal to 0. Now at the end, I'm I'm putting the a at j plus 1 equal to k, that is a at location 0, and I'm putting to number 3. So here I am putting 3 here. And as you see, I've already sorted some part of the array. Okay, so 3, 7, 2, 9, 4, and 8. Now I'm going back again to this for loop, and now I'm increasing I. So this time I becomes 2. Okay, so I becomes 2, and the k will be the value at location 2. That's gonna be also number 2 here in this case. And the j will be I minus 1, that is going to be 1. So for I have this number 2 here. Now I'm going to compare them with these numbers that I have here in the lower indexes. So first I'm comparing the value location 1, okay, and 7 is bigger than 2. So I am now replacing the number 2 with 7. So what happens here, that I will have number 2 will be replaced by number 7. Then I'm decreasing j, so j becomes 0. Okay, so j becomes 0, and then I'm now comparing the while condition is still holds, because also a at the location j, that is 7, 3 is bigger than k, so I'm also updating this value at here, so this becomes 3. And as you see, I'm shifting values to the right. So that's what we said at the very beginning of the this video, that we are moving the numbers to the right. All the values that are on the lower indexes and also bigger than the number that we are considering as the key. Now j becomes -1, okay, and now j becomes -1, so j is not greater than or equal to 0 anymore. So we are putting the a at location j plus 1, that becomes a location 0 equal to k. So now this also becomes 2. So as you see here, we put the 2 here at this location, then we have number 3, and then also we have number 7. So next we are updating I, so I becomes now I becomes 3. Okay, I becomes 3, and then k will be the value at location 3, that is going to be the value 9, and j becomes I minus 1, that is going to be 2. That is exactly the index that is lower than number 3. So now again we are comparing the value at location 2, that is here is 7, with number 9. Okay, so none of the numbers at location j, like j becomes 2, j becomes 1, and j becomes 0, and then so we don't have any changes. So we are putting the a at location j plus 1, that is 2 plus 1 equal to 3 equal to k. So there won't be any changes here for 9. So 9 will be at its location. Now what's gonna happen is that we are updating I, so I becomes now 4, and the value at location 4 will be also number 4. Okay, and j becomes I minus 1, that is equal to 3. Now we are comparing the values of all the values before this index, like 4, that we are now also have the value 4, number 9, 2, number 9, 7, 3, and 2. So here, because a at location j, that is a location 3, is greater than k, so we are like moving this number 9 to the 4. So here this will be 9, and j here will be decreased, and j will become 2. And here, because a of j, that a at location j, that's equal to 7, is greater than 4, so we are also moving this 7 here, so here this 9 will be 7. Then j will become 1, but 3 is not greater than 4. Okay, so it's not greater than 4, so we are not decreasing j. Going back, 2 is also not less than 4, so we are not also changing the so we are not changing j. And then we will have a at location j plus 1, so a at location 2, that we're gonna be key, that is equal to number 4. So here at location 2 we are putting number 4 here. So 4 is also as its location. So number 2 and number 3 were not greater than number 4, so we are not shifting them to the right, okay, because number 4, the key is greater than those numbers. Now on the next phase, on the next iteration, we are updating I, so I becomes 5, and k becomes 8, and j becomes 4. So here our array so far, so we have number 2, 3, 4, 7, 9, and 8, okay, so far. And now we are comparing the number 8 with its location here, with the value 9, because 9 is greater than 8, so we are moving 9 here, and we are decreasing j, so j becomes 3. Okay, now we are comparing value 7 with 8, but 7 is not greater than 8, so we are stopped here, so it goes out of the while loop, and we are putting the value at location j plus 1, that is going to be a location 4, equal to the key, that is going to be equal to a. So here this value also will be 8, and as you see, the array is now sorted. We have number 2, we have 3, 4, 7, 8, and 9 that are sorted. So that's the first array that we use insertion sort to sort these numbers. Okay, and as again what we did that every iteration we had a key, and we were comparing all the values in the lower indexes, and if they were greater than the key, we were moving them to the right, we were shifting them to the right, and then we were like putting the key on its location, that is like between the values that are greater than that key and the values that are less than the key. Now we are going to sort array B. So array B, as you see, is already sorted. So we're going to see that how insertion sort works. So at first, A is equal to 1. Okay, so I is equal to 1. Okay, so I is equal to 1, and K is A at location J, that's going to be number 2. And J is also equal to 0. So if you compare the value at location J, that is number 1, with key that is equal to 2, you see that number 1 is not greater than 2, so we are getting out of, we are exiting the while loop. Then I becomes 2, and again the key will be number 3, and none of the numbers, again 1 and 2, are greater than 2. So we are not going inside the while loop. And also for the rest of the array, this is going to be the case. So as you see, we are not running the while loop at all, and the number of times that we did some operation was from I equal to 1 to n. So that's tells us about the base case of insertion sort. So insertion sort at the base case will be from the base case will be big O notation n. Okay, and this happens when the array is already sorted, because we are not going inside the while loop and everything is its location. And definitely the worst case will be when the array is at the reverse order. So the worst case will be when the array is already is on the reverse order, and it's gonna be n squared. And the reason is we'll have the for loop for I equal to n. So we'll have n, and that should be multiplied by how much we are going into the the while loop that we have here. So j will go will be the maximum number of j will be the I minus 1 when I is equal to n. Okay, so we'll have the second while loop for n about n times. But when the array is already in the reverse order, okay, so we have every key will be back because let's say that we have this array C here. Okay, let's write it with another color. So C, and let's say have it 6, 5, 4, 3, 2, and 1. Okay, so here if we have this first we have this 5 as the key, we need to swap these values. Okay, so these values 6 goes to the 5 and the 5 goes back here. Then we have these 4, and because 5 and 6 both are greater than 4, again we need to move 6 and 5 to the right, and then moving 4 here. Again with 3 is less than 4, 5 and 6. So we need to shift all the values here from the the numbers 6, 5 and 4 to the right, and then moving 3 to its location. So as you see, we are going inside also the while loop, and because the second the while loop will take at most also n times, so together the worst case will be n squared. And also in that average case, the insertion sort will take n squared. So far we discussed binary sort and bubble sort and insertion sort, and both algorithms are stable. As remember, we said that the stable sorting is when you are not doing the sorting. Okay, you are not making the changes to the order of the values to the keys that you have. So here, if we have, for example, two here, let's say that we have another array. So I am gonna get this array here we have, and let's say we have another array here with these values 1, 2, 2, 3, and 4. Let's say we have this array, and the insertion sort. Okay, this this number 2 here that we have has gone before this number 2. So again, after we sorted this number 2, okay, will show up before number 2. And this is like when we have, for example, some key like the key value pairs. Let's say that this is A and B associated with these numbers. Okay, so when we are be sorting this array, again this A will show up before the value B. Okay, so that's gonna be about insertion sort.